Okay, in an earlier video, I showed that delta x is equal to the initial times delta t plus 1/2 a times delta t squared. I also showed earlier that v final is equal to v initial plus a times delta t. Or I can say, in fact, that v final minus v initial is equal to, v final minus v initial over a is equal to delta t. So let's take this and put it in this equation right here. Then I have that delta x is equal to v initial times delta t, which is v final minus v initial over a, plus 1/2 a times v final minus v initial over a squared. But that's equal to v initial times v final minus v initial squared over a from this term, plus a over 2 times v final minus v initial squared divided by a squared. This a takes out one of these a's, and I can write this as 1 over a times v initial times v final minus v initial squared from this term, plus 1 over 2 times v final squared minus 2 v final v initial plus v initial squared, like that. And then I can just simplify this a little bit and write this as 1 over a times v initial times v final minus v initial squared plus v final squared over 2 from that term minus v final v initial from that term plus v initial squared over 2. Notice that this term and this term cancel out, and I'm left with, let me move it up a little bit here, I'm left with delta x is equal to 1 over a times v final squared over 2 from this term, and minus vi squared plus 1/2 vi squared is equal to minus vi squared over 2. So that's equal to 1 over 2a times v final squared minus v initial squared. Or I can write it as v final squared minus v initial squared is equal to 2 times a times delta x. And this is a very useful form of, or a useful connection, I should say, between delta x and v, because it doesn't involve t. It's very useful to solve problems where you don't know the value of delta t.